let's see if we can review what we did yesterday. So we said that if we had a complex number like that, I can change this into a polar form, right? So in the polar form, we said was going to look like this, which is really r cosine theta I sine theta, right? Where r was going to be equal to what? Square root of a squared plus b squared, and theta was going to be the arctangent of b over a here, right? It's y over x, right? B over a, b over a. So r, this was called the modulus. This was called the argument, right? Okay. So that's in a nutshell what we did yesterday, right? In a nutshell, that's what we did. We talked about the Z1, Z2 being R1, R2, and then cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2, right? We talked about that, how you just add the arguments, multiply the modulus, and you renew with Z over Z2, it would be R1 over R2, and you subtracted the arguments, right? Okay, that's where we were at. So that's what we talked about, really, in a nutshell. So that's what we did. So let's see if we can move on, and we're going to do now powers of our complex numbers. So what that is this. So if I have Z1 is equal to R1 cosine theta 1 plus I sine theta 1, and I say, well, what is Z1 times Z1? Z1 times Z1, I have to multiply this by this, right? So basically it's R1 squared plus R1 times R1, and I'm going to get cosine 2 theta 1 plus I sine 2 theta 1. Does that make sense? Because I'm adding theta 1 plus theta 1, so it's basically just 2 theta 1, right? And I can continue this to say Z1 to the nth power would be R1 to the nth power cosine n theta 1 plus I sine n theta 1. Correct? Right? Does that make sense? So if I do nth power, so this is where you truly benefit from the polar expression, right? Because if it didn't give you this, imagine doing 1 plus root 3, I think we're going to do this here pretty soon, but to the 8th. It's a lot of multiplying by itself, right? Right? At the very least, you're going to have to do this squared, and then you're going to have to do that squared, right? And you're going to have to do that one more time, right? Right? So there's at least 3 times, correct? Not that you're going to do all 8 times, right? But still, that's a lot of work.
Yeah.
Okay, all right. So let's see if we can do, let's go ahead and read page 507. So exactly now we are actually going to read the de Moivre's theorem in the blue box there. See if it makes sense to you.
Who's
De Moivre. I would guess he's a French guy, don't you think?
Most likely.
Some French
we don't assume
mathematician.
here. We don't assume here.
I root 3 to the 3rd. Okay, so let's see if we can do this. So in order to do this, I have to change this, which is in a Cartesian form, into a polar form. So this is going to, what's the modulus going to be?
I root 3. 4.
Square root of 4, right?
Oh,
You have to
right.
square root it, right?
Exact same thing.
You did it last time.
It's okay.
So at least you're consistent. You're consistent.
I did the exact same.
Hey, 3rd time's the charm, buddy.
Right?
Okay, I won't.
Does that make sense? So I pulled the 2 out, right? So I have to, so now when I multiply it back in, I get 1. When I multiply this back in, I get this, right? And now I'm going to take this to the 3rd. So I have to change this into polar form. So this is going to be my cosine theta. This is going to be my sine theta. Right? So which theta gives me this cosine value and this sine value?
So the first one,
What is it?
pi over 3.
Pi over 3, that is correct. 60 degrees, 60 degrees, right? And I'm going to do the to the third, right?
Oh.
Which is pretty simple, right? 2 to the third cosine pi I sine pi, right? Because the 3 goes into here, right? Pi over 3 times 3, pi over 3 times 3, so it's pi and pi. Okay, so this is going to be equal to 8. Cosine pi over 1 is, and cosine pi is -1. This is 0.
Oh, it's all 0.
Isn't that so simple? Isn't that just,
Oh, well, it's
how beautiful
Much,
is that?
Much better.
Right? You take this and you cube it, and you get -8. So beautiful. Anyway,
There's also
so
calculator.
since I have to write this out, okay, I'm going to tell you right now, since mathematicians are kind of lazy people at sometime, you can see that this theta and this theta is always going to be the same, correct? Because it's the same argument, right? It's the same theta, right? So commonly, our cosine theta plus I sine theta is written as RCIS. Our cosine plus I sine theta. CIS. Okay, CIS. Everybody see that?
Sounds like a
Okay,
all
all
right.
right. Okay. So that's example number 5. Let's see if we can do example number 6. Example number 6 is kind of the same thing. Example number 6. We have find a negative root 2 over 2 plus I root 2 over 2 to the third, is it? Oh, to the 8th, I'm sorry, to the 8th. Okay. So what is we need to find the modulus first.
Should be 1.
Looks like 1, right?
Yep.
Because this is 2 over 4. When I square it, it's going to be 2 over 4. Add together 4 over 4. 1. Take the square of that. 1. Okay. So all I have to do now, all I have to worry about is the argument, right? So I am in which quadrant?
Second.
Yes, second quadrant. So it's going to be. Oh, there's a 1 here. I'll just write the 1 just to so it kind of looks nice for you. CIS, what is it? Yeah, 3 pi over 4, right?
Yeah.
Good job. 3 pi over 4. To the 8th. To the 8th, right?
Yeah.
So I'm going to get 1 to the 8th. I'm not going to write that anymore. CIS. This goes underneath here. 6 pi.
Huh.
Which is the same as
0.
or 0, right? Same thing, right? What's cosine 0?
I think it's 0. Wait, no. Oh, 1. 1.
It's 1. 1. Sine 2 pi is 0. So this becomes 1 plus I 0.
It's 1.
Again, how simple and beautiful is that?
It's still fairly complex.
Okay.
Less complex.
Okay, so that's example number 6. All right, so we are done for the day. We will do the roots of a complex number tomorrow. Okay, roots of a complex number. So I want you guys to work on your homework, but as you're working on your homework, I assigned, I think, I want to go over some of the stuff so that we can kind of refresh this. Let's see if we can do 33, 36, and 37 together. These are questions that I have assigned on the homework. So I'm going to do some of your homework with you. Okay, so if you can do that. So we'll do 33. We are on page 512. 2. CIS. 3 pi over 4. Is that correct?
Mm-hmm.
And we're taking this to what power?
The third.
Third power?
Yeah.
So what do I get? Well, I want to do this first. What do I get? 8, because it's 2 to the third, right? 2 to the third power. It's 8. And then I'm going to get CIS 9 pi over 4, which is the same as pi over 4. Why is it the same as pi over 4?
Because you would circle.
Because I just turn, because
Yeah.
it's 2 pi and then pi over 4, right? So it's basically pi over 4, 8 times, what is cosine pi over 4? They're the same, right? So actually, if you wanted to go further, I can say 4 root 2 times root 2. Root 2 cancels out. Or 4 root 2 plus I 4 root 2, whatever, right? Either way works. Are we good?
Would you prefer answer like?
I'll take
Okay.
this, I'll take that, whatever.
Always gonna clarify.
Okay, that's 33. Let's see if we do 36. 36 is a little more interesting, maybe because you're doing it to the 20th power, which we do every day, right? Every day we want to know the 20th power of this. 3 plus 4i. 3 plus 4i to the 20th. Okay, so what's the first step? What's the first thing I need to find?
Oh, you're R.
I need to find the r, right? So what's the r here?
Yeah.
9 plus 16 is
5.
25. The square root of that is 5. 5. And this to the 20th. So this is whatever that guy's, I have no idea what that is. And then it's going to be CIS. Well, actually, let's not do this yet. 5 CIS. And this is going to be what? 53.1, I think? Is it 53.1 degrees?
Oh, no. Oh, yeah,
We did this yesterday. I think it was 53.1. To the 20th, so now I can say 5 to the 20th, CIS, and, okay, 106.2 degrees. Because I'm 20 times whatever that is, right? Which would be, that is correct, yeah.
And that's the final, that's it?
Well, almost. Then we have to go, what? This is 360, 720,
That's like
10,080, right?
almost over 300.
So it's 1080 would be 3 revolutions around, right?
Yeah.
So this is the same as,
Oh.
right? And, well, it's this. Well, I already did the 20th, so I don't need that. So it's this is it. Right? So you need to put that in your calculator. calculator to find out what it is. Okay. 37. Yeah, so on the test, if you leave it, you can just leave it this. I'm not going to ask you to write out the string of numbers that represents this. Okay. As a matter of fact, don't do that because it just confuses me.
I'm curious now.
Okay.
I have to check if every digit is actually correct.
Actually, yeah, I know. I don't want to do that. So I'm going to have 1 minus root 3I to the third. That's 37. 37. Okay, so what's my R value here?
2.
1.
Oh wait, 1
Plus,
minus.
you're good.
Yeah,
1 plus
okay,
3, which is 4. Square root of 4 is 2. So it's 2 1/2 minus 3 over 2I to the third. Now I need to change this into a polar form. So I get 2 CIS. Which angle gives me this?
Which pi? No. 5 pi over 3. No,
No,
4.
no.
You're right.
He's right.
5 pi over 3. 5 pi over 3. To the third. 2 to the third. CIS 5 pi. Because I multiply this to this, right? That's why I get the 5 pi. Which is the same as pi. 5 pi minus 2 pi is 3 pi minus 2 pi is pi, right? So I get pi. CIS pi. So cosine pi is -1. Sine pi is 0. -8. We good?
Mhm.
Okay. All right. We're going to call it a day today.